Hello and Assalamualaikum. My name is Fatin Basira binti Azman. My matric number is DF210094. Okay, I'm from Group 5C, will presenting Intro and Methodology. Our group have decided to choose Kelantan as our location, as Kelantan known as frequently flooded state. So for water station, we choose station Tok Ajam, station Pasir Putih, and station Kampung Wakaf Raja. For water level, we choose Sungai Semarak, which is located at Pasir Putih. We use the official portal for the Ministry of Environment and Water Malaysia Department of Irrigation and Drainage as a source of information. The objective of the Water Resource Management and Hydrological Division, firstly, to manage the country world-class hydrological network, and second, providing high-quality data for operational hydrology, water resource assessment and research. Its duty include gathering and processing hydrological data in order to develop and manage present and future water resource. For methodology, we have two methods, which is website and Google Earth. For website, we take data directly from website which had provided, and the information was entered into a Microsoft Excel file. And for Google Earth, Google Earth is a computer software that creates three-dimensional image of the Earth using satellite imagery. Okay, the use of Google Earth for this project was to gather the necessary information for the selected station. That's all for me. Thank you.
Hello, my name is Muhammad Aiman bin Jami'an. My number matric is DF210096. Today I want to talk about the data collection that we do based on website. This daily rainfall data is taken daily for 5 weeks from 1 April 2022 until 5 May 2022. The station select for this data collection are in Pasir Putih, Kelantan. The name of the station is Tok Ajam, Pasir Putih, Kampung Wakaf Raja, and the daily water level at Sungai Semarak. This is the daily rainfall data graph. As you can see, the highest rainfall data that we have is during 5 May 2022, which is 69. The second is at Pasir Putih. The highest is 51. And the third one is at Kampung Wakaf Raja at Kelantan. This is the graph for daily water level. After that, we need to do the hydrograph. The hydrograph that we select is during 4 April 2022. This is the data that we collect from the website. After that, we need to calculate the discharge based on the formula. And the second one is we need to calculate the base flow based on straight line method. After that, we do the direct flow. The formula is simple: discharge value minus base flow. After that, we calculate the UH ordinate based on the formula. This is the data that we get. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and a very good evening I bid to Dr. Hatimi and all of my friends. So today my name is Nadia Kastrina binti Maridan, matrix number DF210082. I'm going to present about the analysis and result in this study. So for the first one is the rain profile and gradient slope. So we choose 3 rainfall stations. The first one is Tok Ajam, Pasir Putih, Kampung Wakaf Raja in Kelantan. So percent slope formula is rise over run times 100. So the rise is elevation for station 1 minus station 2. Example calculation is this one. Station 1 is 4 meter, station 2 6 meter, and the distance 2980 meter is the run. So when we get the rise, we're going to divide it by the distance, which is 2,980 meters times 100. So the percent slope for the first one is 0.0671%. So same goes to station 1 and station 3, and station 2 and station 3. So for percent slope for station 1 and 3 is 0.2769%, and for station 2 and station 3 is 0.34%. All of this calculation using the same calculation from the first one. So next is catchment boundary. This is our catchment boundary that includes all the stations in the catchment boundary. Next is we're going to find the mean aerial rainfall. So the arithmetic mean method, distant polygon method, and isoheutal method will going to be used in this part to find its precipitation. So for arithmetic mean method, we're going to choose 7 days data, which is from 4 April to 10 April, to find its average precipitation. So this is data from station to Ajam, station Pasir Putih, and station Kampung Wakaf Raja. So for arithmetic method, example calculation for this part is total up all the rainfall data and divide by 7. 7 is the days value, 7 days. So 42 over 7 is 6 millimeter for to Ajam, and 10.64 millimeter for Pasir Putih, and 13.07 millimeter for Wakaf Raja. So we're going to find average precipitation for all of these 3 stations. So total up all the precipitation from these 3 stations and divide by 3. So the average precipitation is 9.9 millimeter. Next is by using distant polygon method. We're going to draw the polygon by using Google Earth tool. So for area 1 is 3.94 kilometer squared, area 2 1.75 kilometer squared, and area 3 is 6.94 kilometers squared. So we're gonna multiply the area and precipitation, and the total of area and precipitation gonna divide by area. So example is 132.97, the total area times precipitation, divide by 12 and 63. So the precipitation is 10.52. So the difference is not so big. So for isoheutal method, we use interval 1, 0, 1, 1, 2, 2, 3. So we still use the same, so we're going to use Google Earth Pro to find its area, and average precipitation is the midpoint for isoheutal travel, and we're going to multiply the area and average precipitation. So the total we're going to divide by the area. So the precipitation is 11.31 millimeter. Next is we'll calculate the peak flow by using rational method. So this is table 3.6 show value of outer roughness. We choose paved land surface, which is 0.015, and recommended runoff temperature, we choose link and terrace over 10 URE, which is 0.9. So catchment area 78, outer roughness, recommended runoff coefficient like the table I have shown before. So the slope of upland surface is 0.228%, and the overland flow time is 32.78 minutes, and we will transfer it to ITF curve, and we get the intensity rainfall, which is 150. So we're going to find the peak flow by using the formula Q equal to ICA over 360. So 150 times 7,800 times 0.9 divide by 360. So the answer is 2,935 meter cube per hour. So the discharge of the cross section, we use the Manning reference coefficient, we choose 0.035. This is the slope area of the river. And cross section 1, this is the visualizations. So the slope 4 minus 1, it divided by the length of the cross section. And this is the weighted perimeter. With depth, we're going to use this for cross section area. And hydraulic mean radius R, this is the formula R equal to A over B, which is cross section area and weighted perimeter. So, and this is Q equal to 1 over N, A R power of 2 over 3, slope of power of 1 over 2. So this is how to find the hydraulic mean radius and discharge. Same goes to cross section 2 and cross section 3. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Rukaya Al-Husia binti Azlan, number matrix DF21024. For the discussion, our group have discussed the result of daily rainfall and water level datasets. which we have obtained from the InfoBanjir system. Rain patterns vary by the terrain type and location. The characteristics of the rain, such as amount, frequency, and intensity value, play an important role in determining the rain condition, whether light, moderate, heavy, or very heavy rain. From the categorization of rainfall intensity in 1 hour by the Department of Irrigation and Drainage, it shows that station Pasir Puteh and Kampung Wakaf Raja can be categorized as heavy, as their readings of the rainfall data exceed 31 mm. Meanwhile, the station to Ajam can be categorized as very heavy with the reading exceeds 60 mm. However, we can say that there were no precipitation occur if the reading is 0. Lastly, water level has 4 levels, which is normal, alert, warning, and danger. Station Sungai Semerak shows the water level is below 2 meter every day for 35 days, which is in normal level. For the conclusion, as is widely recognized, rainfall data is necessary for the mathematical modeling of extreme hydrological events, such as drought or floods, as well as for evaluating surface and subsurface water resources and their quality. Lastly, monitoring groundwater flow can help to detect possible changes in water flow, or increase or decrease levels of water volume, which may indicate flow path change or alert to potential surface level flooding. So that's all from our group. Thank you very much.